My name is Lars Rymell. I'm actually a consultant working with optical design. And I work with a company called Eclipse. I will say a little bit about that, but not that much. I think it's very nice to be here today, and I've had two really interesting talks. These talks have been from not from the same area as me. I'm more from the technical area because I'm a physicist. So my talk will be a little bit more from the physics point of view and technical point of view. But I really enjoy this mix when you meet people from other areas. That's what makes my work very interesting. And I've been working with optics for 20 years, something like that. I started as a laser physicist, but then I've been working with optics and photonics for many years. I will be talking about engineering light. It's not that, it will be not that much engineering, but a little bit. I want not talk a lot about our company, but I have to say some things. It's not a selling presentation, but we are consultants working in optical design. We were 5 people starting it 3.5 years ago, and now we are 14. And we are only optical designers, everyone. 12 PhDs, so it's lots of academia in the group, but it's also a lot of product experience. We are product developers. We have been working a lot with developing products, optics for products, lots of consumer products and such things. We have offices in Stockholm and Malmö, and we work not only with lighting that we will talk today, we work also with cameras, sensors, everything that has to do with light. So light is my passion, and I'm an evangelist for light. So I really enjoy being here today. What we do then, just a few things that we have done, just to show you a little bit of our areas. We work with a lot with automotive. We work with active safety and such things. We work with cameras and different sensor systems for autonomous drive and such things. But we also work with consumer products. So actually we have made this illumination in Husqvarna's latest sewing machine. So that was nice to do. But we also work with energy environment, solar power. This is a solar parabola from Cleanergy in Gothenburg, where they have a 9-meter diameter solar parabola that they focus light onto a starting motor actually, and generating energy that way. And we have lots of life science. We work with microscopy and illumination in microscopy. And then it's really technical illumination. You need so much light in that place, and then we calculate that. So that's all about Eclipse. We heard today interesting talks, and we have heard this before. We heard this about the blue LED. And for me, it's really the revolution of lighting. That's year 0 for me. 1994 or something like that, when Professor Nakamura and friends started to develop this blue LED. Actually, I'm so old that I worked in a time where there was almost no blue LEDs and there were no white LEDs. So, of course, the first years it was very weak, this LED. So when I started to working with blue LEDs, you could have it for indicators in mobile phones. You remember the time when you didn't have a touchpad. You had keypads, putting blue LEDs there. That's when I started working with LEDs. And then, of course, you could see how the development came. It started with mobile phones, and then we started to get, of course, this is red light, but still, we started to get LEDs into automotive. This is a gearbox. And then later on, when it becomes cheaper, you could have it in consumer appliances like dishwashers and such things. But the light was so weak then, so you couldn't use it for really illuminating things. Actually, I remember sitting calculating for a flash for a mobile phone, and we had 6 or 7 white LEDs, and we still couldn't get enough light to use it as a flash. It was really ridiculous. So, and then if someone told me then in a few years you can have it in a car as a headlight, I wouldn't believe them. So it's really been a revolution. Of course, when you talk of indoor lighting, where you use LEDs, I think it was a quite slow start, because this was the old lamp and this was the new lamp. You still have, of course, you had LEDs, but you didn't use the potential in an LED. You put them in the same armature and the same things. Of course, it was efficient, and but it was quite blue, and you didn't use it for what it could be used for. So it took some time. So this was early after the millennium shift that they started to do this. But then suddenly something happens. And we have heard a bit about this before, but of course, where you can do much more with your indoor lighting. And this is actually IKEA Flowalt, I think it's called, where you have illuminated panels, and you can do so much more. So you can really, it would it will really make a big shift in making light indoors. Sorry for my English sometimes. So that's interesting, of course, but also making, of course, the changing the colors. This is Philips Hue, came some years ago, and we have heard this for blue light and red light. Actually, I have at my home, I have this blue light in the morning and red light in the evening, and I think it's okay, but maybe it's more in my own brain. I think it's okay for me. But of course, then you can start to use it in another way. Actually, these types of panels, we have worked a little bit with that at our company too, and you can do quite funny things. Because what these panels are basically, it's just a glass plate, and you put a LED strip in one end, and the light is transferred into the glass plate and leaks out, approximately the same as your optical fibers. And we try this by putting light into a glass plate and writing at the same time, and then suddenly it looks like your text is suddenly glowing from this glass plate. Sorry? No, that is frosted, but that's not frosted. No, but you have a pen, and when you write on it, you change it leaks out the lights. So but it's basically the same way that these are working. Of course, it's not only humans that are affected by light. Plants are affected by light. I just want to put that out too. So this is a company in Gothenburg, Heliospectra. They work with designing light for greenhouses. And by changing the wavelength of the light, you can make the plants grow faster. They were quite famous some years ago because their systems were used for growing cannabis, actually, but you can use it for other things too. And that's very interesting. Very interesting science is done there too, and see what you can do by changing the properties of the light and what it makes for growing. And for the future, since we have to grow more plants because we need more to eat for everyone, so it's very interesting to this science that is done in that area. So that's indoor lighting. Of course, there is outdoor lighting too. We have heard. I also have interesting in this light pollution, and of course, LED is responsible for light pollution. But if it's designed on the right way, you can. Actually, I think you could decrease light pollution too, because when you start with this first traffic or street lights, you really didn't use it in the right way. But that's why you really need an optical designer to take care of the light and really use the light in the right way, so the light goes to the road and not up in the sky. So that's, of course, LEDs will bring more pollution, but if you do it in the right way, I think you can decrease it. And then, of course, what we have been working a lot with is illumination for vehicles, automotive. And you become quite a nerd. My colleagues and I, we go out for lunch and we see a new car and everyone goes, "Oh, how is the headlight designed?" And suddenly the alarm goes off and you have to run away. but it's really interesting to see and see how the different companies getting better and better. So and this is actually a Mercedes, and if you start by the headlights, it's really nice design. Now you have this multi-beam LEDs. I think they have 84 LEDs in their headlight, and you can turn them on and off independently, and that means that you can when you have your strong beam on, you can actually find areas that you don't have the strong light. So you can still have strong illumination out on the side, but you don't dazzle or blind the vehicle you meet. So that's really nice technology, and I think Mercedes was the first company working with that. And then, of course, it's design too. You can use this lighting to really diversify. Why should I buy a BMW or why should I buy a Volvo? Because it looks different, but every car looks the same. But if you really, I think making the illumination and the lighting in the right way, you can really use that for improving your brand too. So that's also interesting. So that's an interesting area. So how do you then, if you come to this nice headlights, how do you do this in an engineering type of way then? And that's where I've been working a lot with, and that's actually designing good light, as we call it, light simulation. And light simulation, we talked about trial and error before, but we really think that it can be good to calculate a little bit sometimes too. So we work with simulating our optical systems. So this is just an image of an LED, just an LED illuminating a surface. So this is actually simulated illumination, which we have used with ray tracing software. And this is the same as a photograph. Just ignore this stripe, it's just a measuring probe there. So it's actually a photo showing the same pattern approximately as the simulated one. And this is a very simple example, but that's what we do all the days, sitting with computers and trying to optimize systems before making prototypes and before building the systems. We think you can save time by simulating to start with. Of course, then you have to test the things too, but we do lots of simulations. And one example, what we do a lot is getting even illumination. And then if I come back to these headlights, we see again, this is the Mercedes headlight. This is a headlight of another car maker. I won't say what, but I really like this nice design here, and I don't really like that that design. I don't want to see the LEDs actually in that way. And another nice feature for Mercedes is, of course, this is the indicator when you go turning around. People don't use that anymore, but really when you use, you can indicate when you're going left or right. It's a nice thing, and it's yellow. But actually, if you don't use it, like many people do, it's white. So you can really change the color of this stripe. So then it's a position light. But it's quite even and very nice illumination, and that's actually lots of projects we work with is achieving nice illumination. And then we also use ray tracing software. So this is just an image from a ray tracing we have done, putting different LEDs. And what we want to have is a very nice illumination up here where you don't see the LEDs. And of course, we try to mix the light as much as possible. And then you can do with, in this case, with a light guide here and a diffusing surface or scattering surface. And that is actually what we simulate how the illumination becomes then. And in some ways, you don't really need this light guide. It's just a good material having a scattering surface. So this is just a prototype we made in our lab just to look at how good you can get. And actually, this is only LEDs and a scattering surface, and it can get it quite nice actually. So that's what we work with a lot. The last really example on that, which is really more, if I talk about this one, is that can be indicators for some kind of appliances, something that you would like to have look nice. It can be your TV keypad or something that should look nice. But in some cases, you really need very good illumination. And this is an example of a company, Profoto. I don't know if you know it. They make professional flashes for professional photography. If you look at top model, it's their flashes they use actually usually. Profoto, they are. If you need a flash, you need to have really. You need much light and you need a very even light. So that's very difficult to achieve in some ways. So then you really need to do these simulations. So this is a simulation we have done together with Profoto of the lens for their new flash A1 that they released, I think it was 3 weeks ago or something like that. And my colleague Olof actually made this lens and he's very, very happy with that. And I think they were happy with it too. But that's also very interesting because if you're talking with this type of photographers, they want to have even light, they want to have much light, and they want to have a little bit scratchy light, and that's difficult for me as a physicist. It was a little bit scratchy, and sometimes they say in Swedish krispigt ljus, and we want to have figures, we want to have specifications. It's very difficult to really to understand sometimes. But it's once again this when you meet artists together with technicians, it's very interesting and see if we can find something together. But this was a very nice project I'm working with. So actually that was all I was going to say today. So I'm happy to answer any questions, and yeah.